All right, let's get right into it. If you've been following tech at all, it probably feels like this term deep learning just came out of nowhere and is suddenly, well, everywhere. And you're not wrong. It really started to explode right around 2013. I mean, this stuff is completely changing our world. It's behind everything from our streaming recommendations to the chatbots we talk to. So the big question is, why now? What was the magic trigger that made this revolution happen when it did, and not, say, 10 years ago? That's exactly what we're going to break down. So here's our game plan. First, we're going to talk about the fuel for this whole thing, this insane ocean of data. Then we'll look at how all that data actually led to way better performance. After that, we'll get into the engine that made it all possible, the hardware revolution. And finally, we'll see how a smarter, simpler design brought it all together before asking what's on the horizon. Okay, first things first, let's talk about the fuel. Seriously, without this one ingredient, none of what followed could have happened. We're talking about something we all helped create, a just mind-blowing amount of data. Just think about the timeline for a second. Around 2008, Facebook really hits the mainstream. A couple years later, smartphones are in basically everyone's pocket. And boom, suddenly you have an explosion of content on places like Instagram and YouTube. We all, kind of overnight, became data-generating machines. Every single photo we upload, every video we watch, every comment we post, it all came together to create this massive, unprecedented ocean of raw material. And it just so happened that this data was the perfect food for a brand new kind of algorithm. And that leads us straight into our second big pillar. See, it wasn't just about having a ton of data. It was about discovering this really powerful, almost magical relationship between the amount of data and how well these new models could perform. You see, with older machine learning, there was this weird problem. You could keep feeding an algorithm more and more data, but eventually, it would just hit a wall. It stopped getting smarter. The performance would totally plateau. But deep learning models, they're completely different. They are incredibly data hungry. The more you feed them, the smarter they get. There's no ceiling. As you can see, the performance just keeps going up and up. So this is the light bulb moment, right? That massive explosion in data that we were all creating led directly to an equally massive explosion in what these models could do. It was a perfect match. But having all that data and these amazing new models is kind of useless if you don't have the engine to actually run them. And that brings us to the third key to this whole puzzle, a massive revolution in computer hardware. For the longest time, training models like this was just ridiculously expensive. Only a few giant labs could even try. But then, a bunch of things happened all at once. Hardware got way cheaper and way more powerful. Companies like NVIDIA started making these specialized chips, GPUs, that were perfect for this kind of math. And then, cloud computing put all of that power within reach for pretty much anyone. And that was the game changer. All of a sudden, the biggest barrier, the sheer cost of computing, was gone. Any researcher, any startup could suddenly afford to train these huge, powerful models on all that new data that was available. Okay, so let's recap. We have the fuel, the data. We have the performance, the more data, the better. And now we have the engine, the hardware. But there's one last piece, and it's a really clever one. It turns out deep learning was just a smarter and simpler way to build these systems. So the old way of doing machine learning was this really clunky two-step process. First, you'd need a human expert to painstakingly look at the data and manually pick out what they thought were the important patterns. This is called feature extraction. Then, and only then, you could train a totally separate algorithm on just those handpicked features. And here's where you see the genius of deep learning. It just skips that whole manual step. The process of finding the important features is baked right into the model itself. The neural network learns what's important all on its own. It's one single, elegant, end-to-end process. Honestly, this is a huge deal. By combining these two critical steps into one, deep learning didn't just get simpler, it got way, way more powerful. Especially when you're dealing with really complex stuff like images, sound, or language. So, what happens when you put all these pieces together? The data, the scaling, the hardware, and the smarter architecture? Well, you get an absolute explosion in what's possible. This whole new way of doing things, fueled by all that data and running on super fast hardware, suddenly gave us the tools to solve problems that we used to think were, well, basically impossible. Really sophisticated challenges that require a deep understanding of messy, real-world patterns. And you see the proof of this every single day. It's how your phone recognizes your face. It's how chatbots can actually understand what you're asking. It's how Netflix knows exactly what movie you're in the mood for. These are the kinds of complex problems that deep learning now makes look easy. So let's tie it all together. This whole revolution wasn't just one thing. It was four key things hitting at the exact same time. We got an ocean of data to act as the fuel. We realized that deep learning's performance scaled up with that data. We got cheap, powerful hardware that made it practical to actually do the training. And finally, we got a smarter, integrated architecture that let us point all of this at problems we could never solve before. It really was the perfect storm. The right kind of data, the right kind of power, and a fundamentally smarter architecture all converging. That's what created the world we live in today. And it really makes you wonder, now that this incredible engine has been built, what impossible problem is it going to solve next?